Thank you. Software craftsmanship. Ooh, interesting. This talk is not about clean code. This talk is not about um, it's not about unit testing, not about sprint, not about frameworks, not about technical stuff. It's about culture. It's about becoming better, ways to grow better, you and others. Let's see. Software craftsmanship. I'm Victor Rentea. I'm from Romania. I'm a Java champion, one of the several in Romania already. I've been working in Java for quite a while, and I'm doing trainings for a living. This is what I'm doing. I'm going and talking about Spring Hibernate, functional programming, domain-driven design, clean architecture, refactoring, unit testing, TDD. This is the stuff that I'm doing, right? Every day, basically, with a few exceptions. So besides that, I also do conferences and meetups, like I'm doing right now with you. So if you want to keep in touch with me, I will invite you to join my community, and my community has a very interesting name. My community is called the Bucharest Software Craftsmanship Community. Now, what do you know? Bucharest Software Craftsmanship Community. We are I think, the largest developer community in Eastern Europe of software craftsmanship, but Meetup is down. This was a live panel of meetup.com. Anyway, if you want to join my community, that's completely free. And the stuff that I'm doing for the people are also recorded on my YouTube channel. That being said, what I'm usually doing is trainings at different companies, and also do mixed groups and record video lessons. That's me. Now, let's turn back time a bit, back to the days in which at the beginning of the software, of what software means. At the beginning, there were only craft persons, but to be honest, the most were women. So let's start by saying that when I mean craftsmanship, there's just a word, right? The craft person, if you like, it doesn't make any difference if you're a woman or a man. Just to be very clear, right? As a matter of fact, one of the best developer I ever worked with, Bianca, she's Bianca. So, and they had to do everything. But that thing changed at some point. That thing changed at some point. Now, 10 years ago, 15 years ago, maybe even closer to the moment, the developers and the testers. Oh yes, developers and testers. Now, you can't possibly think very nice, you, a developer, you can't think very nice of someone that comes to you sharing that, hey, you have a bug. You can't love him that much, until he draws a gun, of course. So you can't. It's natural. He criticizes you, right? He says, "Hey, you have a problem." Right? So testers appeared, and then system admins. A system admin is supposed to guarantee stability, while the job of developers is to change stuff. So the conflict is natural. What we see today, even in many companies today, we see weird things like developers without admin rights on their machines, or restricted software. You can't install the software you like. You have to be on the corporate portal, on the software portal. Right? Weird. You don't want to mess up. You don't want to mess with developers, really. So the point is roles, multiple roles. Then the DBA came to the party. Hey, there is this role of a DBA. Oracle invented this job of a DBA. A DBA will always try to keep stuff inside the database. Will always try to keep the behavior in the database. Where a developer, he classically thinks of database as a detail. Right? Now, both are bad, but there is another trend now. Let's ditch the relational databases and let's re-implement everything from scratch in an NoSQL. That's even worse, giving up the consistency of a relational database without gaining anything, right? So, all right, all these things, these other roles came into conflict with developers, but developers themselves, started fragmenting with time, starting building isolated communities. Like, for example, developers working in proprietary languages. Right? I had some clients several weeks ago about that. Dynamic languages, developers that you work in JavaScript or in Python or in languages which are interpreted, right, not compiled. Game studios, which have a completely different approach to building everything, basically. Backend systems are built differently. Everything is different in a game studio. They have a different culture. And then Node.js people is reinventing stuff that was already known for years. And then 2000, in 2000, front end and backends, again, separating even more the community. If you ask a front end, the front end is all good and nice, but in backend, God help you, right? If you ask a backend about the skills of a front end, this is what they'll tell you. This is a front end developer that says he can code the backend system. So the communities broke apart. The communities broke apart. But the reality is that it's all the same thing, basically. It's two faces of the same problem, right? And then mobile. Oh, mobile. Okay. Oh, mobile. We have a web endpoint. We have a web app. We have an Android app and an iOS app because they have to be native. They have to be fluid and they have to look nice. So companies, I know many companies re-implementing similar UIs 3 times, producing 3 times more bugs because the teams are different, right? All of this, and even in Java, even in the same language, building backend systems, even there are groups, there are subgroups, there is segregation in opinion, right? Yeah. I had a problem, so I thought to use object-oriented programming. Object-oriented programming sometimes is thought to be like, yeah, that old thing that we learned in faculty, right? If now functional programming rocks, yeah, leading to weird, and leading to what? What's this? What? Why? Why are we separating like this? Now, a word here. These three paradigms, procedural, object-oriented, and functional programming, there is no best one of them. No, there are different techniques to apply for different kind of problems. You want super high parallelization, you want reactive programming, okay, go functional. You want guard against invalid mutations, you want behavior next to state, you want domain-driven design, go. You want to implement some simple transformation, go. So you don't need to choose one, right? There are different techniques to use in different contexts. But people, when they learn something, they get very attached to that, and they believe, they feel like that's the next best thing. Right? It takes years, maybe 10 years, until you realize that there are actually different tools to use in different contexts. Right? So here we are, broken apart into all these subgroups of people fighting each other and having conflicts between one another. Right? So all of that because of one thing, because of overspecialization, because we would like to see only our part of the problem. We want to look at our part of to our job only, not nothing else extra, which leads to slow projects, large teams, and a low track factor. A track factor means the number of members of a team that needs to disappear for the project to be in big problems. Right? If only one guy, if you have only one front end and he leads, God help you, right? And if no one else knows front end, you're dead, right? Or back end, even worse, right? So what then? What then? There is another bad thing that happens. If someone tries to implement a wheel but doesn't know about the wheel because it's not his world, he will do over engineering. He will overcomplicate the problem because he will use the tools he is comfortable with. Right? This is bad. So what's the solution to all this? Having a collective code ownership. This is not just a dream. This can happen. This is true. What does it mean? It means that you need to learn all the parts of your project, not just your part. You need to expose yourself to more of the components, of the features, of the traits, of the things that make up your project, right? And then you can help anywhere it's needed. And then you don't need to delegate. You don't need to call someone, hey, can you put a button on the screen? No, you can take the screen and change it. Hey, can you put this new Maven in the pipeline on Jenkins? No, you can change it yourself. You control. Of course, with great power comes great responsibility. So you should be careful what you're doing. You are more responsible, but many seniors, many persons with a of great value, they are looking for jobs that give them the power to cause impact, to do impact, to have impact, right? Maybe a mid-junior will look for a salary, but then after a while, what attracts people is the ability to ship stuff and to do an impact, right? But you have to be responsible for what you're doing. So I'm really talking about becoming more full stack. But don't ever try to become a full stack expert. There is no such thing as an expert in full stack, except if you're using JavaScript everywhere. Even then, Even then, no. There is no such thing like a full stack expert. Just look at this Java developer looking at an npm install running. This is you Java looking at npm install. How could you know all those goose, right? You can't. It's too much to know. Frontend has grown too much for you to control, to understand. So it's not about becoming expert everywhere. It's about becoming the so-called T-shaped developer. What does that mean? It means you have a core competency in one area, okay, of course. But then once you master your area, you don't stop, but you start to learn laterally different parts surrounding you in the same project. Now, the T-shaped developer or the V-shaped developer is something that it gets there with years. Now, of course, when you start your career, you will start with the I-shaped developer, having a little competency in your core system, and then you grow your competency. And after you become an I-shaped developer, then you start caring more about the team. So an I-shaped developer is all concerned only about his role. A T-shaped developer looks for the team. It's better for the team to have developers of T-shape that don't only look at their part, they look around and try to improve stuff around. So why full stack? Because you will be more flexible because you have to learn continuously, right? You won't be afraid of something that comes to artificial intelligence. So what? You will be in the mindset of learning, right? Also, being in the mindset of learning, it helps a lot calming down egos. There are many seniors out there which are very full of themselves. So, being always in the mindset of learning helps enormously about that. Also, better welded, more better teamwork. Because I myself am a backend guy, right? But if by formation, but if I would like to do some changes in the screen, I will try to do my stuff. But if I'm not able to, I will have to talk to someone from frontend. So team building happens weekly, happens daily. When you feel you are out of your comfort zone, you might want a second opinion, and you talk more to each other, which is very good. So I'm doing trainings for a living for more than 2 years. I've been in more than 100 companies, thousands of people I've seen, and I've seen how many teams. The best teams I ever saw, trust me, are those that are full stack, because they have to talk to each other a lot. They have to be a team, right? You can't just be back and front and DevOps. No, it's a single team. It's a very fun feeling, a very fun feeling. And then you yourself, you are more useful, more adaptable to new tasks, and thus you could earn more if the company has a certain mindset, right? Full stack. And now what's next then? Then when you have a problem, you don't just try to solve it from your part of the world. You will get your hands dirty, go into JavaScript, do the stuff there, or vice versa. Adjust the stuff in the backend endpoint, right? You don't just patch over it. How many times did you had to solve a problem, but solving it on the other side of the fence was too hard for you, so you did a hack on your side. Not to call anyone, not to talk to anyone. No, I want you to go and try to do it there. If that feels too hard for you, call for help. But don't just restrict yourself to your area and then throw the task over the fence to someone else, right? Because in the end, this leads to simpler code. You solve the problem where is most simple to solve. At that point, you don't patch over the other parts, right? And then you become pragmatic. You become pragmatic and you start caring about what really has to be done. But you have to learn. You have to learn a lot. Learning is not compulsory, neither is survival. I don't think anyone can survive in computer science, in IT, without learning continuously. I really don't think so. I mean, you can't. There are too many things to learn. The first 3 or 4 years, you learn a language, your framework, your libraries, and then you learn design patterns, clean code, and then you learn testing, and then you learn to behave like a human, and then it's continuously learning experience. You can never stop, right? So myself being in this branch of teaching people, I get this question very often. Hey, what should I learn next? I have this free time, and what should I learn? Or what I want to invest in myself. Where? What to study next? You could start reading about microservices, even if you are not using it. But will that help? Will that knowledge settle in your brain? Will you get to a deep understanding of those concepts? Or do you want just to put the microservices in your curriculum, in your CV, in your resume? So what my advice is to master the technologies of your current project. If I mean, the most true deep learning happens on the job, on the tasks that you have. So the next bug you have, try to deeply understand what was the root cause of it. Don't just patch until it's gone. Try to understand really hard why the bug occurred. Right? Read books, read chapters, read documentation, dig, dig, dig. Reproduce the bug in a synthetical environment just to prove to yourself that you understood what was wrong. This is how I learned Hibernate, right? And then always when you stay in code, you don't just do your stuff and leave. You always look for alternative design. I know that some of you are scared of the code that you live in. I know. I've been there. I've seen that. But I'm talking about thinking. How would I implement this in a different way? How can I twist it? Maybe tomorrow, maybe the team, maybe together, maybe not. But the idea, how can we improve stuff, should always be in your mind, should always be a goal, right? So technical. T from technical now. T-shaped developer means you learn more from these technologies that you use surrounding you. But there is more than that. There is more than that. You know, developers are special in a sense. Are special because no ambiguity can ever pass through us. We can't talk to a business guy and then he's very fuzzy usually. I have many clients that tell me, hey, business changes their mind every week, or they don't really know what they want. It's natural for a human, but not for a developer. You can't be fuzzy with bytes and processors. You can't. You have to write sharp code. So we, the developers, back in the 90s, there was an attempt to remove developers from the software development cycle with the so-called case tools that were supposed to write code instead of us. It failed miserably because no machine can ever understand what goes on in the brain of a business, right? So our most important goal, I'm not sure if you realize this yet, our goal is, we are unique not by the fact that we know Spring, Hibernate, or we know microservice or domain-driven design. No, we are unique by the fact that we are irreplaceable because only we are able to extract what is the real need from the mind of the business and translate it into executable code. We are the gate between the humans and the machines. We need to translate stuff. So here's the client trying to explain stuff to the business analyst. The business analyst explains stuff to the developer, and the developer writes code. And there should be continuous communication between the two. If there is no continuous communication, if there is someone else who is impeding it, look what happens. The poor client wants to draw what? What's that? I don't really get what's that, but it has a head and a body and hands, and then some feathers or something. The business analyst draws a bird, right? Let's see what the developer does. Developer, oh my god. Excellent! This is what you get in the code. Why? Because of misunderstanding. So it's obvious. The more chains the more links in the chain, the more the chance to misunderstand yourself. So I'm talking about having an intermediary which is not doing his best to facilitate the communication. I'm talking about a scenario in which there is someone in between impeding your communication. I know there are some scenarios in which developers do not want to talk to clients because the clients maybe don't have time for them. Maybe they are super specialized, like in a financial institution. Sometimes it's very hard to talk to such a guy. Not impossible, but very hard. Right? So in such a case, you might actually need this guy, but this should be super motivated. Right? You should never ask him, "Hey, what should I do for this case?" Or "I didn't get that point." Whenever you ask something to the business analyst or whatever product owner, you should get a response immediately or very soon. This guy should be highly motivated. Otherwise, it will impede everything. It will impede everything. And there is one thing that the customer explained, another thing that the analyst designed, another thing that the programmer implemented, and then the customer is invoiced, and not only then he realizes what he really needed, right? So you don't want to play this game of misunderstanding each other. Now, people realized that thing long time ago, 21 years ago, the agile software development appeared. They realized that they want collaboration, that they need working software, not some documentation. They need interactions between humans, right? This is the goal. Very fun fact. You know who this guy is? This is Martin Fowler, probably one of the most technical guys on earth. Kent Beck, the inventor of unit testing, Uncle Bob, the author of Clean Code, right? These are the most technical guys on planet Earth, and they were in the room. There was no manager in that room. There was no product or project manager in that room. There were only hardcore developers who gathered together to find ways to be more effective, to do more impact with their work. Right? Nowadays, if you ask someone, "Hey, are you agile?" the answer that you'll get is, "Yeah, we have Scrum, but we are digital transformation. Yeah, we have Sprint. Yeah, we move fast." This is what I see most. This is what's most appealing to business. Hey, they can run fast. The developers run fast, so we can throw late changes at them. They will still do it. This is what is appealing to management. This is what they want out of agile. But wait a second. And then they try to push Scrum on us, and they give us post-its, and they say, "Hey, let's do agile." But agile is not shitting software based on post-its. Agile doesn't meant that. Agile didn't meant that. Agile was crafted by people who were hardcore developers. The best developers on planet Earth gathered, sit together, and they came up with these ideas. So where is technical excellence in all of this? Where is it? It got lost. It got lost between Scrum planning and grooming and running fast. It got somehow lost in between. So here is software craftsmanship, trying to restore back the focus on the lost technical practices. This is software craftsmanship. Software craftsmanship means professionalism of a software engineer. Software craftsmanship means you have a code of ethics. I will not harm a colleague. I will not ship shit. I will only push with reliable tests. It's like taking an oath of professionalism. This is what software craftsmanship is. Right? Now, if you just spend a second here, if you realize these two professionals are saying technically the same thing as the first one. Because if you ship shit now, or you don't have reliable tests, someone else will get harmed later. So it's about being professional. And software craftsmanship also had a manifesto of their own. They said not only working software like an agile, because working software can be shitty software. We want well-crafted software that allows us to steadily add value and not paralyze after several years, not slowing down after several years. Software craftsmanship means a community of professionals, right? Software craftsmanship means partnership, not only collaboration. You mean partners, equals partners. Developers say things, business say things, we together as a team have a product, right? Now, what does it take to get there? So you are a developer, right? What should a software craftsperson do? Now, one of the core skills of someone who wants to be a professional is to be able to talk to customers directly. You should want to do that. If your context doesn't allow, okay, maybe it's hard, maybe it's tricky, maybe you have to learn a lot. Okay, I understand. Maybe you need to have the product owners or business analyst together with you in the meeting, but you should never run away from talking to the final client, with the one that has the budget and the requirement in his mind. Okay, then a software craftsperson can understand the real business problem. And that's not easy. My God, no, it's not easy. What do they really need? And then propose solutions, even if those solutions don't involve coding. And this is where it gets scary. What? Should I get myself fired or what? It's about finding the problem and then finding the solution that gets there with the least amount of effort. Perhaps it's easier to buy a solution than writing software. Perhaps it's easier to externalize a part of the system to someone else. I don't know. Right? Think out of the box, not in code. Right? A software craftsperson is able to break down some requirements, some fuzzy requirements, into some very sharp, user-centric stories with stories that happen. Right? A craftsperson is able to design a UI flow. I know that's very unusual for a backend, but hey, these are the screens. You go from here to here. Where do you go next? You go to that screen, or you go back here? What conditions? And the feeling, the user experience of the application. Right? Now, of course, a software craftsperson can write working code. can write tests that will avoid regressions later on. I mean, unit tests or integration, automated tests, right? And then evolve the design by refactoring, but not just superficial refactoring, deep refactoring of the model. Those of you aware of domain-driven design, that's what I mean. Deep refactoring of the model to align it better to the reality of the problem. This is the skills of the software craftsperson, right? And also deploy and have an idea and control about the pipeline of your deployment to some extent, of course, depending on how large is your company. Now, a classic software developer will only focus on writing working code. Now, I don't think I need to convince any of you that writing automated tests is part of your job. I think we all agree. And I think also we all agree that refactoring is something we need to do continuously to make sure our code doesn't degrade to an unmaintainable mess. But after you master these three, which are, I believe, I see, these three are accepted to be your responsibilities. Besides those three, you need to look outside of the box and ask, hey, if you master those three things, if you know how to do this, the next step you could take is go and try to do that, try to do more of the stuff that comes before or after you writing software. So as a first next step, I will take it from scratch, from very beginning. Suppose you're like absolute junior or medium, someone just starting their career. I don't know, 3 years of experience, 1 year. No. The first thing first, you have a bug. You will have bugs. Breaking news. You have a bug. How do you fix it? You reproduce it, you fix it, and you're happy, right?
Isn't that cute? But that's wrong!
Very wrong. Don't do that. First, write a failing test. See the test red? That's a sign of strength. And then fix the test by fixing the bug. I know that it could take you 6 hours to write this test and 5 minutes to make it pass. I know. That's a sign of maturity. You are covering a land full of bugs with a test. Next day, you will have a test in the same place. Actually, it was scientifically proven that in 20% of your code reside 80% of bugs, the same Pareto rule. So a small part of your code contains most of your bugs. If you put tests in that area, those tests will help you write more such tests tomorrow, and also will avoid regressing back and having the bug again. So I'm talking about replacing debugging with testing, right? And of course, testing run by your Jenkins, by your pipeline. Now, what this means is that if you don't have yet a pipeline that is able to run all your tests, this is the first thing you need to do. You need to ask, why isn't my pipeline running all my tests? Hey, I need the test containers. Let me spend time there. Engage in meetings. Try to get all your tests to run on Jenkins continuously. Maybe not all at every commit, but at least daily, maybe twice per day, depending on how big they are. But your tests should run continuously, and you optimize the runtime of those tests to be as fast feedback as you can get. Right? This is the first step. And then the next step, looking back. So where am I going? I said we all start here. We all start by writing code, but then we write automated tests, and then we evolve by refactoring. Because if you don't refactor, what you get is this: patching over patches, and so on, under design, a system that will degrade. Now, when agile movement starting gaining traction, there was a concept appeared of emerging architecture, of a design that will emerge in time as you add more features to your application. But the problem is that such an emerging architecture sometimes never emerged because business never gave you time to refactor, because you never thought of stopping the development just to clean up your garbage. Because perhaps you weren't aware of where you get if you don't refactor consciously. Perhaps you didn't have the skills to refactor properly. Perhaps you don't know that you can do 80% of refactoring is 100% safe with IntelliJ or a reasonable editor. So perhaps you didn't know this, but this can be fixed with practice. But when I say this to my groups, to my training groups, they say, when When the heck can I do that? If my life looks like this, when can I practice? So what are you telling me? I should what? What do you mean practice? They don't give me time to learn, right? Now, Sandra Mancuso wrote a wonderful book. To be honest with you now, after I read this book, I started my community, which has now grown. Let me do a retry on this webpage. These are not so. We have a, which has more than 4,000 members right now. After I read this book, I founded my community. The book says to this question, okay, I understand. The management doesn't give you time to refactor. I understand. But who owns your career? This is a groundbreaking question. What do you mean who owns your career? Are they supposed to give you time to practice? And to quote the book, when you go to a medic, to a dentist, are you the client supposed to give him time to practice? Are you supposed to pay for your dentist training? No, it's his responsibility. He's a professional, right? He's a professional, so he trains. My wife's a medic. She practiced surgery on synthetic, hundreds of hours of surgery on synthetic materials just to get a hand, just to practice and to learn how to do that surgery, eye surgery, right? So who owns your career? Questions I will ask at the end, if possible. Please, Stefan. I saw your question. I will at the end. I want to not to break the flow here. It's carefully designed. So the point is that you have to stop and to have time to reflect about what you're doing. But the problem is that performing every day doesn't give you room to learn by making mistakes. You can't afford trying out a refactoring idea and then breaking production. It's not professional. It's as if you are always on stage. So this is the feeling. But you need time to reflect. So what am I saying over here? I'm saying that you should invest time in training yourself. Now, if you are lucky enough to be in a company which acknowledges the need of learning and which supports you by giving you, I don't know, 1 day per month, 2 days per month to learn, or that pays for your trainings, or that cares for your learning, then you are a very fortunate person, right? But if not, that should not stop you. I mean, replace Netflix with what? With practicing. You know what this is? This is an apple. Huh? Apple? Is it an apple? But what's this? This is, my friends, from a surgery book. Organic model for the training of basic surgical techniques. You are supposed to resect a skin tumor with a certain margin without breaking a lot of tissue. Practicing on an apple, right? Practicing on an apple. So this is if you translate this to programming, it's a coding kata. It's when you practice to improve your design skills, your refactoring skills, your testing. There are several types of such coding katas. In case you want to see where you get one, actually I could actually Google that. Just a second here. It's called Catalogs. Very good site with a list of all the katas and all of them have, for example, Christmas light. Let's see. This is if you follow the links in here, you will find starting code, ugly code that you are supposed to clean. For example, if for a refactoring exercise, right? Then you clean it without rushing, without risking, because this is not production code. This is an apple, right? And you aim for perfection. You repeat as much as you can, as much as you want, until you get there, until you are happy with your result. And not only with the result, you are happy about the way you worked. So hey, can I do this refactoring in a easier way? Yeah, how? Like this. And you practice, and you practice, and you practice. If you lack ideas, I have a playlist on my website with some kata that I recorded, and you can watch what I did, and you can try to emulate what I did. Go here with the talks, and there is a section about my best talks, something here. Search, it's there. I don't find it right now. Good. So coding katas, exercises to refactor, to unit test, because you want to master that. After you master the language and the framework, I don't know, Java, Spring, Hibernate, Java 8, Lambdas, the next step is unit testing and refactoring. And once you master that, and you practice, you do coding katas alone, you do coding katas with your friends, in mobbing or pairing together. And you practice, and you challenge, not only in terms of refactoring and testing, but you challenge yourself perhaps in terms of learning a new language. Um, uh, the way the way I write Java after I learned Scala. You see what I mean? Learning a language can open your eyes into different ways. And if you want to learn a language, if you are backend like most of you are, I would suggest you learn TypeScript and then Kotlin. If you're a front-end guy, then maybe learn Java. Okay? If you know both, maybe try Clojure, try Swift. Amazing language, by the way. Try C#. I don't know. Open your mind, right? These first ones are the most mind-blowing. I think Clojure should be here also. So try to implement such a kata, and all those katas have different starting. You can write those katas in different languages, and then challenge you more. Challenge you more by trying to explain stuff to non-technical guys, non-technical folks, right? This will work on your communication skills, because in the end you have to be able to talk to the client and to negotiate the scope of the changes they want, the amount of to negotiate, to tell you, hey, I can give you that, I can give you that. There should be an ongoing communication and negotiation. And then also reasoning, the critical thinking, hey, I start a pet project, what do I care more about? Or contribute to open source, or maybe only think about how a business runs, to learn about money. How does the money flow? How are we paid for our? How much are we paid for our? What other costs are in the software? To have the idea, the overall idea. Good. But all of this requires continuous learning, continuous struggle to grow. So you, as a senior, as a lead, as someone who cares for the others, you want to establish this culture of learning, because this will provide this, let's say, the framework, will empower people to open their eyes and not only focus on their problem, but then focus on testing and refactoring, and then opening the up and okay, let's front and back, and okay, functional and object oriented, okay, and then next what? So you want to get your developers to maturity as fast as you can, if you care for your teammates. So you want to establish this culture of learning. And let me share with you several tricks I've seen used in many companies, in many and other and outside. One trick, very easy, start a book club. Actually, this is what I did at the first years on my community. I did more than 100 such debates on a chapter from fundamental books like Clean Code, Refactoring, Software Craftsmanship. We were reading one chapter, and Friday we were debating what was in that chapter. Super cool. Now, why? What happens? It's the effect that we all do that. And so it's a chapter. A chapter takes you to read what? 1 hour? 30 minutes? So you read that chapter. You have 1 week for that. And then you hear others talking about the stuff that you read. And you debate. Super fun. Super fun. The best way to learn, right? Brown bag section. Also during the lunch, you present your problem. The others eat. I don't care. And maybe someone has an idea. Hey, but you have to prepare a bit to present your problem. Maybe draw a picture, take a photo. Look, here's the problem. Right? Or make a shared blackboard or shared whiteboard to draw together in a remote setup. Right? Another thing that the best companies I know do, they rotate developers. What does that mean? For 2 weeks, you work for another project. Or for 2 months, you work for another project. And then one developer from that project comes to your project. So they swap developers. Why? To open their eyes, to come with a fresh perspective. You don't need to hire someone new in the company to get a fresh perspective. Especially in a corporation or a large company, there are different ways of doing stuff in your ecosystem. Share, swap, if they want, of course. But you should maybe even stimulate them. I know they won't be that productive, but the point is to bring a new perspective and to ask for clarification, to ask questions to the other project. Questions that might make them see things. Hackathons. Hackathons, like, I don't know, we stay one evening together and we try out some business idea, or we try out some larger refactoring, for example. Then afterwards, we remove everything and we think, what does it worth or not? Group code reviews. Another thing, why to do code review one-to-one? If it's something fun and interesting, bring it up with the entire team and have like a team design meeting or a brainstorm together with all of the team. Right? Establish communication of practices. which means that all the React developers part of a group. They share, they do tech talks internally, and you don't just create a mailing list and you're done. No, you stimulate people, give them incentives. I don't know. You find out what to do to make people share what they know, the pitfalls, the best practices, right? Communities of practice. And then, as I said, motivate people to share and to teach others. Because the best way, of course, to learn something is when you teach someone else. This is why I got into teaching, because I wanted to make sure I learned stuff correctly. So explaining it to someone else was the best way to prove that I really understood. Right? Join the community. And pair programming. Encourage pair programming in your team, in your company, in your department. Encourage pair programming. Okay? Encourage pair programming, because for some tasks that require more design, more brain, more refactoring, more ideas, encourage pair programming. Right? So what's the point here? Why? Why all this? Because you want to accelerate the speed that your people learn. You want to make them faster. You want to upgrade their skills faster. Now, at the beginning, I imagine that people will start talking about will pair to learn the framework, perhaps, or we'll let's read about Spring. Okay, fun. But then, once they master the framework, once they master the language, the programming language, they will open their eyes to other things that surround them, things which sometimes have much more impact than just coding. Right? So you want professionals that look around and they say, "Hey, I can do this in a much smarter way." Right? So to do that, you have to get them comfortable with their ecosystem, with their immediate surroundings first, and that meaning test and refactoring. Okay, so you learn language, you learn the framework, then you learn testing, you learn clean code and refactoring, and then you focus on other stuff that is involved in the project, in the making of a project. Right? This is how it works. I remember there was a fun quote that the bookshelf, the book library of a junior is full with books about frameworks and languages, right? Now, the bookshelf of a senior, of a seasoned senior, are full of books about applied psychology. Because you, as a senior, realize that it's all about teamwork. If everyone plays and everyone does its best, it will be a success. It's not only a technical problem. The real problem is to play nice, to have a nice team, to have a nice feeling, and to work together, to learn together. Super important. And here's another trick I heard recently about encouraging people to talk more to each other and to learn more from one another. The idea is like this: after lunch, just after lunch, during siesta, just 1 p.m., 1.5 p.m., you schedule a 5 minutes discussion with like everyone in the team talks to someone else, asking them if they can help in any way, and vice versa. What's the point? After lunch, many people they block, and if you block after lunch, you will very often block until the end of the day and until the next sprint. So the point is to unblock you on the day, during the day, throughout the day. Then you ask questions. Can I help you? Do you want to chat? Just 5 minutes of chat. So craftsmanship means more than just loving to code. Craftsmanship means to solve a problem, but the road to get there starts by getting better at coding. And how do you do that? Yeah, juniors will always be eager to write more code. It's natural. Juniors like, oh, I want to write code. I want to learn. That's perfectly okay. But seniors, oh my God, seniors can't wait to delete it. Every time they have the chance to delete something, they will. Why? Because seniors know that code can hide bugs, problems. Code needs to be refactored. Code is bad. A senior, just a senior if he can solve a problem without writing a single line of code, he will be the most happy guy on earth. However, a junior, when he can solve a problem without writing code, he will feel disappointed. I mean, I'm not writing code for this. Why? Let me reinvent the wheel a bit, right? So, because the senior realized that what matters is to solve the problem, not just. But it's natural to be like that, because at first you need you are not comfortable in your language or your framework, and you want to somehow prove to yourself also. You want to learn. You want opportunities to learn, right? So that's why this happens. So perfection is achieved not when there is nothing more to add to your system, but when there is nothing left to take away. When the solution is good, but you delete the most code you can. Deriving from this, the habit of deleting unused code or useless code every week, to schedule a 1 hour of what can I delete sessions. You go through code and you ask, is this really needed? Is that really needed? Is that really needed? Of course, you have to have some tests and you have to have some sense of responsibility for that code. But the point is that you need to clean away the stuff that accumulates. It is not really. Sometimes a large part of the method is not used anymore, but it's still there, cluttering the code. Wipe it out aggressively. Go and, is that really used? Let me check. Is that really the case? Let me scan the production data. Is it really ever the case? No. Wipe it out. Right? So in the end, we don't just write code. And this is the moment you realize it's not about writing code. It's about solving problems. It's about solving the problem that you have in front of you. Good. Now, you see, Uncle Bob, you heard of Uncle Bob. He actually wrote a sort of an oath. Right? I will not produce harmful code. What does that mean? You should not write code which is untested, which is a bad factor that will, or the code will do harm. Right? Let's not talk now about Volkswagen. Okay, the code that I produce will always be my best work. What does that mean? You never should rush. You should not allow yourself to be rushed. No? But then you will tell me, hey, if I do that, my business will go crazy. What do you mean? They will force me do that now. The ship, yes, I will ship frequently, but small releases that incrementally add behavior. I will provide with a quick and repeatable proof that it works. Unit tests. I will fearlessly and relentlessly improve code at any occasion, aggressively refactoring. I will not make the code worse. And I can't help remembering the technical debt backlog, the famous technical debt backlog. Teams that produce shitty code for some reason, they add more items to the technical debt backlog. It's like getting the guilt out of your brain and putting it in a document, and then it means it goes away. No, it will come back to you because it's a debt. And any debt is an interest rate. It will harm you. It will accumulate more and more and more, right? How am I kidding, huh? Then, a software craftsperson, I will keep productivity high for me and my team. What does that mean? It means not only that I write tests that allow others to refactor easily without being afraid and paralyzed. It not only means that I will refactor my code to be nice, it means I will seek any kind of opportunity to improve the speed of my release and my productivity. What does that mean? It means maybe automating different chores, different boring stuff. Maybe even doing CI/CD, continuous deployment. Maybe doing maybe involving business more into clarifying the requirements so that you get faster the requirements. All right? I will continuously ensure that others can cover for me and that I can cover for them. This is a track factor, which technically says that you should not be the only one knowledgeable about a certain topic, which directly goes to full stack. Okay? Directly goes to being a T-shaped developer that is interesting to learn more about what happens in your project. Not just your stuff. So open your eyes, start to learn more. And I've seen backend developers, I'm sorry to say that, disgusted of writing JavaScript or CSS. Why? It's still stuff that has to do with your project. Why? So don't run away from that task. Okay? No one escapes JavaScript, I'll tell you that. I will produce estimates that are sharp. I will not make, sorry, what did I do? I think I pressed the wrong button. Yeah. I will produce estimates that are sharp. I will not make promises without certainty. This is a very, very important point. Anything that we are seeing over here, if you don't have time to refine your design, is useless, is impossible. So don't promise to ship something in some time that you don't truly believe it's possible. Better don't say anything. Better estimate the estimation. Hey, it takes me 2 days or 1 day or 6 hours to give you a sharper estimate. Don't blindly just say, yeah, 2 days. Maybe you say 5 days and business says, oh, no, 5. Can't you do it in 4? You should never say, I'll try. Never. If you are not sure that you can do it, don't promise. Don't say yes. Okay? The best you can say is, if you want a sharper estimate, ask me 2 days from now. I can't promise now. I can't say anything now. And the last point, I will never stop learning and improving my craft. Learning. And by learning, he also means teaching others, because that's the best way to learn. So these are the tricks that you should try out to establish this culture of learning that will open everyone for new stuff, right? So what are the takeaways for all this? What are the steps to take? So you are a developer, you are writing code 9 to 5, shipping features, okay, good. The first thing you probably need to start with is to study code smells, to see what, so folks, I'm saying this from a perspective of someone who taught thousands of people, right? So, trust me, study code smells. That's the first thing you want to master. A language and framework, you have no way out. You will have to learn it anyway, but you proactively, you want to focus on detecting problems in your code, micro design issues, code smells, little insights, like for example, feature envy, like Boolean parameters are bad. Why? We are violating single responsibility principle. Oh, we have principles. What other principles are there? Oh, solid. Oh, dry. Oh, keep it simple. So these cosmen will expose you to principles and bad and good and also good ideas about what clean code really is and how and what good code looks like. And then refactoring, the next thing you need, getting fast into changing the code in a safe way, using IntelliJ, using the editor, or if not, writing tests to cover your changes, or both, right? And then the myth of 1,000 unit tests. I've heard this once, I don't know where, but that any developer who has written more than 1,000 unit tests is clearly in a different category than the others. What do you mean? 1,000 unit tests is huge. It's like writing 20 tests per day for how many days? It's huge. It's huge amount of work. But is it possible? What do you gain? If you write many unit tests, the tests themselves, trying to write those tests, will show where the problems are in your code. So trying to write those tests will show you where the problems are. So tests show design issues. Tests show design issues. Trying to write as many tests will make them clear to you. And then try to solve a kata twice. What do you mean twice? Solve it once, solve it again, and again, and again, until the first time you solve a coding exercise. Very important, this one. Coding kata. In case you never heard of this concept before, is a problem. It's a classical problem, which contains some code, which is very carefully crafted in a bad way to make you discover some typical code smells in the code. So it's very hard to create a coding kata. Very hard to write that bad code to start with. But it's super important to start practicing on code, which is not your production. Because with your production, you took decisions about that production. Anything you say against your production goes against your past decisions. So you are emotionally bound to your production code. Don't start practicing on production directly. Start practicing first on external pieces of code. That's why I recommend you take some some apparently simple problem and try to refactor it. You'll be amazed. If you want to have a single one to start with, I will recommend this. How to share this link with you? I will just put it in the screen. Is try to solve this one. It's starting point in Java, right? And a picture and a description very nicely, just good for you to clean it. Clone this, clean it. Okay? This is what I would really recommend you do. Right? So you solve this kata and do it twice. There is a recording online with me solving it also, but don't look at it first. Try to solve it yourself. Look at me, come back, solve it again and again until you're happy with what you get. You can spend up to 4 hours solving it. So take time. Try more programming or pair programming. Super, super helpful. Start with 2 hours per week. Try that. And try always to open your eyes to other things that surround your own piece in your project. And engage customer more. Don't ever run away from a client meeting. I know there are people and people, but do your best to talk to the final client, to refine requirements and to understand what goes on in their mind. This is the only thing that gives us a job, really. The ability to extract requirements out of the business head to get a requirement into code. All right? I'm close to done. So some books. There are more on I have a little blog that I'm trying to write every now and then. And I have an entry about the books that I believe you should write. You should write. You should read. Right? Okay. That being said, I think I'm done. Just if you want to join the largest software craftsmanship community in Eastern Europe, please feel free. If Meetup recovers, right now Meetup is still down. Is it? No, it's up. It's up. Look, my beautiful community. Here it is. My beautiful 4,000. And you know what? I will talk to you next week. Next week, not later. Next week, unit testing. 9 things that your tests were trying to tell you, but you didn't understand. Right? So come, you'll see. It's super fun, all engaging and super fun. More than 100 people usually there, live, remote, and in English. I should say that. All right. Now I think we have time for one question or two. Question for Stefan. If you have full stack developers, how can I? Yes. If you have full stack developers, how do you keep respecting the principle of single responsibility? Very good question. Well, single responsibility principle is about code and classes, code constructs. Single responsibility principle, the S in solid, is about code construct, about methods, and about classes. It's not about what is the responsibility of a human. It's not doesn't have anything to do with developers, teammates, team members. They should have, like I said, collective code. It's not easy to get there. Owners, you have to trust each other. And you have also to have the strength to say, okay, this problem is over my head. I don't know. Let me call someone. Right? It exceeds my expertise. It's hard to say that. It's more than you can take. Right? So collective code ownership, you have to have it. That's the best thing you want. Right? So full stack developers, they will work with each other. Single responsibility principle means that a method or class should be focused on a single job. Or if you want to twist it again, it means you should not try to tackle many things, many complex things in the same place. Break it down into smaller pieces, right? How do you apply this healthy psychology with team lead product owner that don't care about creating a healthy environment, except leaving? No, don't leave. 6 months, you stay there. Stay put. Struggle. 6 months. 6 months, you struggle. How do you tackle? Then you take responsibility. You take that role. The role to create that environment. What does that mean? It means you try to shield your developers. What? The developers, those of us at the beginning of the career, they can't take the pressure from an angry business. This is where you step in. You, the defender of the team. So if someone in the team says it takes me 4 days to do something, to do it well, you say four days to the business, and he says, he says, then this noise never gets to the team. This noise stops with you. Shield your developers. So make sure as a tech lead that what you say to the business is sharp, firm, and you don't start fuzzing. And I know it's hard. You will take a lot of emotional pressure, but that's why you're a senior. That's why you're a lead. Okay? You are supposed to defend your team. I had such a tech lead when I was young. Is the interest for technical debt fixed or compounding? Good question. Compounding. Compounding. And the guy continues. Thank you. Excellent. I don't know. Okay, I think I'm stepping into the break. So maybe that's enough. I only saw these questions by now. If you want to chat more with me, catch up with me on my community. Go here, join this community, and let's have the discussion. Okay, and I will end it here.